Assalamualaikum warahmatullahi wabarakatuh and welcome. We are going to present about application of differentiation is a maximum and minimum point or value. What is differentiation? Differentiation is a process of defining the derivative of a function. The three basic derivatives are, for algebraic function is d h power of n will become nx power of n minus 1, in which n is any real number. For trigonometric function, d sin fx will become f prime x cos x. And lastly, for exponential function, d e power of fx will become f prime x times e power of fx. Differentiation can be carried out by purely algebraic manipulation using three basic derivatives, four rules of operation, and a knowledge of how to manipulate function. These are the trigonometric function list. The four rules operations are the sums, the product rule, the quotient rule, and the chain rule. Where is a function at a maximum or minimum point? In a smooth changing function, maximum or minimum is always where the function flattens out. Where does it flatten out? Where the slope is 0. And where is the slope 0? The derivative will tell us. So, the example questions. The first one is, a ball is thrown in the air. Its height at any time t is given by h equals to 3 plus 14t plus a minus 5t squared. What is its maximum height? So, this is the solution for the questions above. Using derivative, we can find the slope of that function. We differentiate h in terms of t, which we will get 14 minus 10t. Now, we need to find where the slope, where or when the slope is equal to 0. So, we will get the t is equal to 1.4. Then, we substitute the t into the original function, and with that, we will get the height, the maximum height of the graph, which is 12.8 meter.
Alright, for question 2. The sum of two positive numbers is 10. One of the numbers is multiplied by the square of the other. If each number is greater than 0, find the numbers that make this product a maximum, and draw a graph to illustrate the answer. The first thing you need to do is to analyze the problem and formulate the equations that are required. Let the two numbers be a and b, and the product be p. Make b the subject of equation 1 and substitute into equation 2. For step 2, differentiate with respect to a, and then determine the stationary points by letting p prime of a equals to 0. We find the value of a, which makes p a maximum, and then substitute into the equation 1 to solve for b. The fourth step is to determine the second derivative, and then write the final answer. The product is maximized when the two numbers are 10 over 3 and 20 over 3. And the last step is to draw a graph. To draw a rough sketch of the graph, we need to calculate where the graph intersects with the axis and the maximum and minimum function values of the turning points. To find the maximum turning point, you need to substitute the stationary points into p equals to ab squared, and the minimum turning point, substitute 0 and 10 into p equals to ab squared. And all you need to do is sketch the graph. That's it.
The third question is, Michael wants to start a vegetable garden, which he decides to fence off in the shape of a rectangle from the rest of the garden. Michael has only 160 meters of fencing, so he decides to use a wall as one border of the vegetable garden. Calculate the width and length of the garden that corresponds to the largest possible area that Michael can fence off. These are the solutions for the question. Step 1. We need to examine the problem and formulate the equations that are required. The important pieces of information given are related to the area and modified perimeter of the garden. We know that the area of the garden is given by the formula area equals to width times length. The fencing is only required for 3 sides, and the 3 sides must add up to 160 meters, which we can write as width plus length equals to 160. And then we need to rearrange the formula to make W to be the subject for the formula. W equals to 160 minus 2L. And then we need to substitute the expression for W into the formula for the area of the garden. Notice that this formula now contains only one unknown variable. Area equals to length in bracket 160 minus 2L. And then we factorize it as 160L minus 2L squared. Step 2. We need to differentiate with respect to L. We are interested in maximizing the area of the garden, so we differentiate to get the following. dA over dL equals to A prime equals to 160 minus 4L. And then step 3, calculate the stationary point. To find the stationary point, we set A prime in bracket L equals to 0 and solve for the values of L that maximize the area. A prime equals to 160 minus 4L. We substitute that A prime in bracket 1 equals to 0, so 0 equals to 160 minus 4L. And then 4L equals to 160, and then we divide 160 with 4. Length we got 40. Therefore, the length of the garden is 40 meter. Substitute to solve for the width. Width equals to 160 minus 2L. And then we substitute the L with 40. We write as 160 minus 2 in bracket 40 is equals to 80. Therefore, the width of the garden is 80 meter. Step 4. Determine the second derivative A prime prime. We can check that this gives a maximum area by showing that A prime prime is lesser than 0. So, we write A prime prime is equals to negative 4. Step 5. Write the finite answer. A width of 80 meters and a length of 40 meters will give the maximum area for the garden. We wrote the value at here with label width equals to 80 and then length equals to 40.